So we're looking at exponential functions. We're going to quickly go over the rules, take a look at some equations, and show you how to make a quick graph, quick and easy. So there's a ton of rules. Let's go through them one by one. First rule I want to go through is the product rule. You can multiply when two bases are the same. You write the base and you add the exponents. So this doesn't work if the bases are different. If the bases are different, you just leave it alone. But if you have common bases, then when you multiply, you just add the exponents. So for example A, where we have x cubed times x to the 8, just think to yourself, well, I have 3 x's and I have 8 x's, right? Because x cubed is actually x times x times x. So that's 3 x's. Now, because you're multiplying them together, that's how you get x cubed. Now you're multiplying that with 8 more x's. So that means you have x 11 times. So instead of having to go through all of that, all we do is we say 3 plus 8 is 11. X to the 11. For part B, we have 2 to the 4 times 2 squared. 4 plus 2 is 6. And then for part C, we have a little bit more complicated, probably something you might see on your test or quiz or whatever. We have x squared and x cubed being multiplied, which gives you x to the 5. And we have y and y to the 4th being multiplied. Remember that if you don't have an exponent there, that means there's a little 1 there. So 1 plus 4 gives you 5. So that's why you have y to the 5. Now if we look at the quotient rule, quotient is a fancy word for divide. It makes sense that we're subtracting. When we multiplied, we added. So obviously when we're dividing, we're going to subtract. Same thing occurs. You have to have the same base. And you are subtracting the numerator and the denominator. So in our examples, we have x to the 5 divided by x squared. 5 minus 2 is 3, so we get x cubed. For part B, numerical example, we have 3 to the 5 divided by 3 cubed. 5 minus 3 is 2, so we end up with 3 squared. Now part C is something more like what you'd see on a quiz or a test. We have x squared divided by x to just give me x. And then we have y to the 5 divided by y cubed. 5 minus 3 gives me 2. So that's y squared. Feel free to pause at any point in time if you want to write these rules down for your reference. Or take a screenshot. Next up, we have the zero exponent rule. Anything raised to the power 0 is 1. X to the 0, 1. Y to the 0, 1. 6 to the 0, 1. All those numbers and letters, parentheses, to the 0, 1. Very simple rule. The power rule says that if I have an exponent raised to another exponent, we multiply the exponents. So if you envision this with me, on example A, where we have 3 cubed squared, that's like having 3 cubed times 3 cubed, which would be 3 plus 3, which is 6. Now instead of going through all of that, all we have to do is 3 times 2 is 6. For part B, we have 3 squared to the 4th. It's just 2 times 4 is 8. And then for part C, we have 5 times 2 is 10, z to the 10. Expanded power rule, we have multiple terms inside of the parentheses. What you're going to do is you're just going to distribute whatever that power is. So we have x, y to the m, so that should be x to the m, y to the m. Same thing happens with the division. It gets brought to the top and to the bottom. So examples, for part A, we have 2a cubed, so that should be 2 cubed a cubed. And whenever we have the regular numbers, you're going to notice that we're going to simplify that. 2 cubed is 8. 2 times 2 is 4 times 2 is 8. For part B, you'll see that that 2 is distributed, and we end up with 6 squared and x cubed squared, which gives us 36x to the 6. Feel free to pause at any point in time, take a look at all the examples, and take screenshots or notes, whatever you need to do. Negative exponents. If a factor in the numerator or denominator is moved across the fraction bar, the sign of the exponent is changed. So if I have x to the negative m, you know how all numbers are basically over 1? Well, I can move that down to the bottom and it will become 1 over x to the m. The same is true if it's in the denominator. If I have 1 over x to the negative m, I can bring that x to the m to the top and make it positive. If I have an entire fraction with a negative exponent, all I have to do is flip the fraction. So as you can see in our examples, for part A, x to the negative 3 is equal to 1 over x cubed. For part B, we have 4 to the negative 2, which is the same thing as 1 over 4 squared, and that equals 1 over 16. You can take a look at these examples one at a time. Be sure to pause, take screenshots, take notes, try and work them out. These are just here for your benefit. Now the exponent only applies to the factor it is directly next to, unless parentheses enclose other factors. So when we have a negative 3 squared, there's 2 different ways to write it. If the negative is on the inside, then you know that squared will get rid of that negative sign. Any even exponent will get rid of that negative sign. Odd exponents, it will keep the negative sign. But the way it's written in part B, that negative is outside. It's not in parentheses. And so 3 squared is 9 and you keep the negative. Okay? So in other words, you're squaring the 3 and the negative is a separate entity. Whereas in example A, you are squaring negative 3. All right? That's the difference between those two examples.